In this video, we're going to look at how computers subtract. Computers don't subtract numbers the way that me or you do, with kind of borrowing and taking away from columns and lending parts from columns. A computer can only add. So the CPU or the processor of any device you're using, such as a smartwatch, a tablet, a Chromebook, a PC, a server, or anything else that's got a computer in, actually only can add. And what it does is it uses some quite interesting mathematical and computational techniques to make it appear like it can subtract. The same thing happened to multiply and divide. It actually can't do those, but we make it look like it can, and we do some little kind of tricks to make it do that. The method called for doing subtraction is called 2's complement method. Like many things in computing, it was written by a computer scientist who would originally been a mathematician. A lot of things came from maths because a lot of early computer scientists were mathematicians. So 2's complement. Let's put the weighting line down as usual. Well, it looks like it's usual. We'll talk about why it's slightly not yet. 64, 128. We want to get the number 24 as a positive number first. So 24, there's no 128, there's no 64s, no 32s, 1618, no 4s, no 2s, and no 1s in there. To get the negative for that, what a computer does is it actually flips some of the bits there using the 2's complement method. So it starts at the least significant bit and it copies those down exactly the way they are until it gets to the first one. When it gets to the first one, it keeps that one but flips all of the other bits over. So this is a number minus 24 in 2's complement method. Now you might be thinking, hold on a second, that doesn't make sense, sir. There's 128 here. Well, actually, all 2's complement method, the most significant bit is a minus number. In this case, a minus 128. If you want to work it out, you could do this again. So minus 128, if you add it up, it will give you minus 24. So that's how a computer stores numbers. Well, how does this fit in with the maths of getting it to work it out? Let's clear that out. So let's try and do this just with a nibble to make it easy. 1, 2, 4, 8. So let's get the number 12 first. We'll take number 12, 1, 4. So 1, 8, 1, 4, 0, 2, 0, 1. Okay, plus 12. We then want to get the number, let's do 6. The number 6 is a negative number. So what actually happened is the computer takes the second one, the one it wants to subtract, it converts it into a negative number and then it adds the two together. So the number 6 is no 8s. There's 1, 4, 1, 2, and no zeros, and that's number 6. So again, we use that 2's complement method to flip, the flip rule. We keep the 0, we keep the first one, and we flip the other ones there. Okay, so you can see that that is minus 6. If you wanted to really do it, think what this actually is minus 8. Okay, minus 8, now 2's complement. So minus 8 plus 2 gives us 6. So to work this sum out, we'll write it out as usual, 1, 1, 0, 0. We will add on the negative number 1, 0, 1, 0. And we would put the carry line up, but it'll see here to let us know that's the carry line. So a 0 and a 0 gives me a 0. A 0 and a 1 gives me a 1. A 1 and a 0 gives me a 1. A 0 and a 0, sorry, a 1 and a 1 gives me a 0 carry the 1. So we'll come down here. And what happens is we get an overflow error in subtraction, the way it is addition, it will give us this. So if we convert this number back in here, this will give us 6 because we've got a 4 plus a 2 gives us 6. So we can just check that sum. We wrote it out in full as a sentence. 2 minus 6, well, we'd expect it to give us 6, and it has. So have a go at doing some subtraction questions with the sheet that's available, to have a go at using the 2's complement method to work out how a computer actually subtracts numbers.